Physical properties of matter. The first two physical properties that I want to cover are boiling point and freezing point. So let's start out with a pan of water. Here's our pan, and we'll fill it in with some water, some very dark colored water. And of course, since we're going to boil it, we'll need a flame. You'll probably think of boiling as heating up, but I kind of want you to get away from that thought in your brain. What I want you to think of boiling as is adding in energy. So we've got the flame under the pot, and we've got the water in there, and we're adding in energy. Via the flame here. Now at the microscopic level, here's what our water looks like. We're going to make it vibrate or move. And this little vibrations here represent the amount of energy it has. So right now it has like a medium amount of energy. It's existing in a liquid state, so it's vibrating and moving, and the molecules can move against each other. Molecules can move against each other and slide around, and that makes a liquid, right? The molecules move very easily against each other. But now we're putting this flame on it, and we're adding energy into the molecules, and the molecules are going to start vibrating faster. We're going to add more vibration lines, maybe some down here. They're vibrating faster and faster. They're getting more and more energy, and eventually they're going to get so much energy that they're actually going to split apart. And this is what we call boiling point. And that is the point at which a substance turns into a gas. So these will lift off. And you can actually see this when you're cooking food, maybe boiling a pot of macaroni or spaghetti. There's a steam that comes off the top, and that's water vapor, water in a gaseous state, water that has separated from other molecules and is lifting off. The second thing I want to cover is freezing point. Now let's take our pot of water again. So we'll represent our water molecules here. 1, 2, 3, 4. Bad water molecules, oh well. And we've got our vibrations, or our energy, around them. Now we're going to take this and put it in the freezer. So here's our bigger freezer. And we've got the temperature below freezing point of water, which is about 32 degrees Fahrenheit. And what we're doing in the freezer, once again, you're going to think of it as making it cold. But what I actually want you to picture is taking away energy. So we're taking the energy out. Taking energy out of the molecule. So now I've taken away all of the energy that I need to, or all the little vibrations. You'll notice that there's still some left, and that's because in a solid there are still vibrations of the molecules. They aren't totally stationary. So in effect, everything around you is moving very, 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 very slightly. Everything has little vibrations, so small that you can't even feel it or you can't see it. But even solids are in motion. So let's take oxygen. Oxygen is about 21% of our air. And we're not breathing in a liquid and we're not breathing in a solid. So oxygen must have already reached its boiling point because it exists as a gas around us. Now I said I wanted you to get away from the idea that boiling is hot and freezing is cold. Now freezing in this example is going to be very cold, but boiling is also going to be very cold. The boiling point of oxygen is negative 297.31 degrees Fahrenheit. That means all the way down at negative 297 degrees, oxygen by itself has reached the point where it has received enough energy to lift off from each other and become a gas in the air. The freezing point is even more extreme. The freezing point of oxygen is negative 361.82 degrees Fahrenheit. That means all the way down at negative 361.82 degrees, enough energy has been taken out of oxygen to make it stick together, to reduce that vibrations. They cling together. They're still moving just a very little bit, but they're going to condense into a solid block. So at this point, enough energy has been put in that the oxygen lifts off just like water in a boiling pan. And at this point, negative 361, enough energy has been taken out in order to make oxygen that exists in the air around us into a solid block like ice.